Inverse functions, example 3, find the inverse of f of x equals to x squared. So now we're going to find the inverse of the parabola, which is the sketch of the red graph below. We also have a sketch of the axis of symmetry, which is the line y equals to x. Our first step is to identify some points on our parabola. And the first point I'm going to write down the coordinates of is the turning point, and the parabola turns at x equals to 0 and y equals to 0. I can also identify another nice point when x is 1, y is 1. My third point is when x is 2, y is positive 4. And we see that the parabola has an axis of symmetry along the y-axis, so I have on the negative x-axis, when x is negative 2, y is positive 4, and when x is negative 1, y is positive 1. So we have enough points to reflect in the line y equals to x so that we can find the inverse function of f of x equals to x squared. So the first point that I'm going to reflect is 0, 0, and because this point lies on the axis of symmetry, its image lies on the axis of symmetry. The same is for when x is 1 and y is 1. Let's reflect 2, 4 in the line y equals to x, and we know that when we're reflecting in the line y equals to x, we swapped our x and y coordinates, so the image is when x is 4 and y is 2. Let's now do the same for our negative x values. So I'm going to reflect negative 1, 1, and it becomes x will be 1 and y will be negative 1, which is this point here. The last point that I'm going to reflect is when x is negative 2, y is 4. The image of that point would be x is 4, y is negative 2. I also have an additional point at x is 9 and y is 3. And at x is 9 and y is negative 3. So let's sketch the parabola. Sorry, the inverse of the parabola. So this is the sketch of the inverse of the parabola f of x equals to x squared. The next step is to find the equation of this inverse graph. So our function was f of x equals to x squared. We replace f of x with y, so we got y equals to x squared. To find the equation of the inverse graph, we swap our x and y variables. So we're going to go and say that x equals to y squared, and we write it in the standard form. That means we make y the subject of the formula. So we're going to square root both sides. So we get that y equals to plus or minus the square root of x, and so the inverse graph is the graph y equals to plus or minus the square root of x. We're now going to do the vertical line test, and we see that when we sweep a vertical line across the graph of f of x equals to x squared, it cuts the graph at one point only, and so f of x equals to x squared is a function. However, can you see that it cuts, this vertical line will cut your inverse graph in more than one place. It cuts it in two places, and so the inverse of the function f of x equals to x squared is not a function. And because the inverse graph is not a function, I may not write my equation in this format. Let's just look at the graph. We see that the original graph f of x equals to x squared and the inverse graph intersect at 2 points, and they intersect here when x is 0 and y is 0, and they intersect at x is 1 and y is 1, and both points are points on the axis of symmetry y equals to x. So now we have realized that the inverse of f of x equals to x squared is not a function. The next question to ask is, What must we do so that the inverse is a function? And to have the inverse that is a function, we have to restrict the domain. Now at the moment the domain is the values. X is an element of real numbers. Now to restrict the domain, I have one of two options, and I'm going to use the turning point as the point where I restrict the domain. So I could draw my graph for positive x values only. So if I just draw the arm of the graph for positive x values, that means for x greater than or equal to 0, then my inverse function will be this yellow graph here. And if we do the vertical line test, on the yellow graph, can you see that the yellow graph will be a function because the vertical line will cut your yellow graph at one point only. We have a second option. We could restrict the domain for negative x values, so we could draw the arm for x values less than or equal to 0. So for values of x less than or equal to 0, I have the blue arm, and the inverse will be the blue graph here. Once again, the inverse will be a function. So for your quadratic function to have an inverse that is a function as well, you need to restrict the domain, and the point at which you restrict the domain is the turning point. So we're going to have a closer look at the inverse of f of x equals to x squared for positive x values. So we are only concentrating on the positive x values. So we have the coordinate 0, 0. We have the coordinate x is 1 and y is 1. And we have the coordinate x is 2 and y is 4. So we shouldn't actually be drawing that arm of the graph. The only arm of the graph that we're looking at is the graph for x greater than or equal to 0. So let's take these 3 points and reflect it in the line y equals to x, and let's see what the inverse will be. So my first point is on my axis of symmetry, so its image lies on the axis of symmetry, and so for the point 1, 1. My next point, if I reflect it in the line y equals to x, I will have x is 4 and y is 2. I can draw an additional point at x is 9 and y is 3, which is not on my graph. But we see that this is the inverse, and the inverse will be the equation y equals to positive the square root of x. If we conduct the vertical line test, we see that the vertical line cuts my inverse at one point only, so my inverse is a function. Let's look at the domain and range of my original graph. So I'm drawing the graph of y equals to x squared, or f of x equals to x squared for x greater than or equal to 0. I've restricted the domain along the turning point, so my domain will be x is greater than or equal to 0 for all real x values. Looking at my parabola, we see that the range of my parabola is y is greater than or equal to 0. Let's look at the inverse graph. So for the inverse function, we're looking at the graph of y equals to positive square root of x. What is its domain? Can you see that we have x values greater than or equal to 0, where x is a real number? Sorry, I didn't say here that y is a real number. What is the range of your inverse function? We see that we have only y values, so we know that y is greater than or equal to 0 for y, an element of real numbers. So now we're going to look at the inverse of f of x equals to x squared for x less than or equal to 0. So once again, I'm going to consider the point 0, 0. I'm now going to look at the point when x is negative 1 and y is 1. and I have the point when x is negative 2, y is 4. Let's reflect each of these points in the line y equals to x, which is my axis of symmetry. I see that my first point 0, 0 lies on the axis of symmetry, so its image is on the axis of symmetry. When x is negative 1 and y is 1, and if I have to reflect it in the line y equals to x, I swap the x and the y coordinates to find the image. So now I have that x is 1 and y is negative 1. Similarly, if x is negative 2 and y is 4, the image of that point would be x is 4 and y is negative 2. So the inverse function is this graph here. And I've included the point 9 and negative 3. This graph will have the equation y equals to negative square root of x. We're now going to look at the domain and the range of the original graph, y equals to x squared, or f of x equals to x squared for x less than or equal to 0, as well as the inverse. So our domain, we have x is less than or equal to 0, and x is an element of real numbers. Our range, can you see that the y values are positive? So we got y is greater than or equal to 0, where y is an element of real numbers. Looking at the inverse function, the domain of the inverse function is all positive x values. So your domain is x is an element of real numbers, but x is greater than or equal to 0. And we see that the range is y values less than or equal to 0, and y is an element of real numbers. So once again, we see the relationship between the domain and the range of the original graph and its inverse. The domain of f of x has the same values as the range of the inverse function. And the range of your original graph f of x has the same values as the domain of the inverse function. And now, because we restricted the domain, we see that the inverse is a function, so we can write it in functional notation. So we can say that the inverse, which is the graph y equals to negative square root x for x values less than or equal to 0.